Hi everyone, for today's lesson we are looking at this handout over here, okay, CW4/6, building communities resilience to manage the disaster risk. Okay, so make sure you have this handout with you, and we will be going through this handout together as part of this lesson. Okay, so what's this lesson about? Let me rewind back to what you have already done. Okay, we have learned about the different hazards, tectonic hazards, okay, all the danger caused by volcanoes, all the dangers caused by earthquakes, am I right? Okay, so if we look at the nature of hazards, how come volcanic eruptions, how come earthquakes can lead to greater disaster than other places? Okay, so we have looked at, hence, if there's a greater disaster, how do we manage the disaster? Okay, so in the previous handout we look at disaster management. That means when a disaster occurs already, how do we respond to it, how do we recover from it, okay, so that it minimizes deaths, injuries and damage, the DID. Okay, and we also learned that in order to do both the responses and recovery well, although you do that after the disaster has happened, okay, to make sure there's less death, injuries and damage, you need to prepare in advance to make the responses and recovery measures more successful. So this is where we ask the question at the end of the lesson, right? We have this question where if it takes so much effort to respond and recover, and both need some form of preparation, is there a way that we can reduce the chance of disaster happening? Okay, would it be better if we reduce the chance of disaster happening so that even when it occurs, I don't need so much resources to respond, I don't need so much resources to recover, then I can actually prevent high numbers of DID, death, injuries and damage. Okay, so this is why this was about disaster management. Disaster happen already, how do we manage it, how do we reduce DID? So today what we are looking at is disaster risk. That means even before the disaster happens, okay, how can we reduce the chance of DID? Okay, how do you reduce the chance of disasters happening? Okay, so I think you have seen this formula since Sec 3. Whether a place has a chance of disaster happening, whether there's a chance of the high DID, okay, it depends on, number one, what kind of hazard, what is the hazard like, okay, and then we've already done that in 3.2, and then we say that because some places can cause more disasters to happen more easily, that's why we need to manage it through recovery and response measure. Okay, but we also see that the disaster risk, the chance of disaster happening, is also dependent on how much things are exposed to it, how many humans, how many properties are exposed to the hazard. Okay, and of course how dangerous or how protected the people are and their belongings and properties are to the hazard. So actually, right, if we manage these two, exposure and vulnerability, we can actually reduce the chance of disasters happening, even and reduce the need for disaster management. Okay, so which is why we are looking at today disaster risk management. How do we strengthen community resilience? How do we help communities better able to adapt, to respond, to recover from disasters? Okay, so that it will be more sustainable. All right, we'll be looking at how do we reduce the exposure of the community and how to reduce the vulnerability, okay, so that we can prevent disasters from happening despite what hazards we are exposed to. Okay, so let's look at page 2. Now for this video, there will be parts where we will pause and I will get you to think through, try and respond before we talk about the responses to write in your handout. Okay, so there are various strategies, we'll go through them today as part of this video. Alright, so first strategy, we have land use planning. Okay, so please highlight with me, yeah. Okay, so what's land use planning? Land use planning, right, whether is it about tectonic hazards or not, okay, Singapore also does land use planning. Land use planning is just a guideline to decide how land will be used, okay, and it's usually done by the government. Alright, in Singapore, I think you learn in Sec 2, right, URA, they come out with a plan of how Singapore's land will be used. Okay, so in the context of disaster risk management, okay, what is this about? Well, firstly, I will find out from past disasters, okay, and I'll create a map, we call it hazard map, to know which are the places what they are exposed to hazards. Okay, that means these places are likely to have a from here I can tell what are the levels of disaster risk. Okay, so for example, let me show you this example. Okay, so this was constructed from 2010 Merapi eruption. Okay, so based on where the different volcanic hazard has spread, right? Let's say whether is it the ash, the lava, or the pyroclastic flow, they could tell that these are the areas that are most likely the next eruption is going to be high risk. A lot of disaster will happen here. Okay, and then the white color parts, maybe not really disaster may happen. All right, so from here they know which are the places that has high. If I put people there, there's a lot of exposure. If I don't put people, then I need to remove them to reduce exposure. Okay, here's another one from Aceh, Sumatra. So after the 2004 Indian Ocean tsunami, they realized that these are the places that is very likely to be hit by tsunami. Okay, and then the gray area not so much, and then the white area not so much. Okay, so using the hazard map, I know which places are highly exposed to hazards, which places are not. Okay, so what do I do then? Well, for places that is high risk, okay, to reduce exposure, to reduce exposure, I need to minimize the development or control the development there. Okay, so for example, I will not put hospital, crucial infrastructure over there. Confirm will get destroyed, right? Okay, I will not put very expensive buildings or expensive infrastructure there because you'll be destroyed easily. Okay, so how do they do this? After they plan ready, they may pass a law. All right, they make it illegal for certain areas to be there. Okay, they can also do this after a disaster. So like after tsunami, what Aceh did was that when they try to rebuild, right, they rebuild it at a place that has a lower disaster risk. Okay, so these are just details about the individual tectonic hazards you have learned. Okay, what is done with land use planning to minimize exposure. All right, so here begs the question, how does this reduce disaster risk? Okay, so let's do one at a time first. How does this reduce disaster risk? Let's go backward first. What is disaster risk? Okay, disaster risk is the chance of high DID, death, injuries, and damage. Okay, so we must then show that how it reduces death and destruction. Okay, so I will pause for a while and I get you to tell me what are the possible in-between steps. Okay, we shall pause now. Alright, so I hope you have come out with the possible response. So how does this reduce death and destruction? Well, if I reduce the number of buildings and people in high-risk areas, there will be lower exposure. So lower exposure means less people will be, less chance of buildings being destroyed and collapsing because there are less of it there, and less chance of the hazards killing people. Okay, so that's why there's less death and destruction. Alright, the next part, okay, how does this then improve community resilience? Resilience is about recovery, right? How does it help the community recover faster? So with less death and destruction, how does it help the community recover faster? I want you to give it some thought, and I'll pause the video before we go through. Okay, I hope you have decided already. So with less death and destruction, basically it is easier for them to recover, right? Less death means less trauma in the community. Less destruction means less rebuilding needed. I don't need to spend so much money to rebuild and recover. So that's why it's easier for them to recover back to their normal lives. Okay, so recover and return to normal life. That is an example of resilience. Okay, last one, sustainable. How do I show that something is sustainable? All right, I'm sure you remember from your Sec 3. Okay, and we've been talking about it. Sustainable has got to do with lasting into the future. Okay, so how do we help the community last in the future? How does less death and destruction help the community to last into the future? I'll give you some time to think about it and pause the video. Okay, have you decided? Well, if less death and destruction, of course people will feel safer. Okay, so if they feel safe to stay there, of course they will not move away. Alright, that's why the community can last into the future. Okay, so feel free to pause the video if you need more time to see the words to write down into your handout. Alright, now that we know that it's effective, then why is it not effective then, or what makes it less effective? All right. So if I zone already and realize that there's development there, let's say there's a lot of let's say I started hazard map, okay, or let's say this one, actually I zone already, zone, then I realize that there are very expensive buildings here, okay, there are rich landowners here with maybe tall office buildings. All right. So if I don't want them to be exposed to the disaster, I will want them to move. Okay, but I cannot just force them to move without money. I need to pay them to cover their loss. Okay, so because this moving is when they are forced to move, right? Okay, I need to compensate them, and by compensating them, it is very expensive. It's very costly. So for certain countries, especially for the less developed countries, the LDCs, they cannot afford. Okay, so I want to implement this. When LDCs, it's hard to implement this. Okay, because I may not have the money to force people to move. So that's why it's not so effective for some cases. Okay, for some cases, especially for tsunamis, I want people to move away. I want them to leave. Let's say, for example, Aceh, right? After the 2004 tsunami, they actually forced the villagers not to rebuild at the coast. Okay, forced them to move here and rebuild here. Okay, and the villagers, of course, they protested. All right, because number one, this is the land that they have been living there for generations. It's their ancestral land. It's important to their community. How can you force them to move? Okay. And the second thing is, a lot of these villagers are fishermen. All right. So what? Every day I must take my boat, travel 2 kilometers into the ocean, put my boat here, then go out for fishing, come back, drag everything back 2 kilometers. All right. It's not possible, right? Okay, so some may want to continue to stay there because of the traditions and their way of life. All right, so they are very unwilling to move. Okay, so despite having such measures to reduce exposure, people may not want to be moving, or people may not be able to implement this. All right, so as a result, despite all the things that you have put in, there are still a lot of people being exposed to the hazard. Okay, so if more people are exposed to the hazard, what happens? Of course, it's the opposite of this lah. There is more chance of death, DID lah. Okay, so this is the limitation. Why? Yes, it works, but there is also reasons why it may not work for some cases. Okay, or certain situation. Now, I want to pause the video, and I want you to use the things that helps to build community resilience, how to make it sustainable. I want you to think, how can it be applied here, to explain why with all these limitations it may not be able to build community resilience so well, and it may not be so sustainable. Okay, I'll pause the video. Okay, have you decided? All right, so why is it that it reduces community resilience? Well, because if there's more death and destruction, it is harder to recover law. All right, I need more resources, the people are more traumatized. Okay, so if it's harder to recover, the opposite of this, people will feel less safe they're unable to recover, and then as a result they might want to avoid all this, and they will leave. And when they leave, the community cannot last into the future anymore. Okay, all right, so this is the effective part, this is the not effective part. Okay, so overall, is it effective or not effective? It depends on the situation. You need to weigh. Okay, that's why we don't make a decision for you, because it depends on the question, depends on the context given. All right, so there are more examples over here which I've talked about already. Okay, and you can look through to better understand this measure. Right, on your own, please decide, how does this strengthen community resilience? Does it increase preparedness? Does it reduce exposure? Or does it reduce vulnerability? Okay, we will discuss this in class next week. Okay, so moving forward, let's look at the second one in page 4, which is about hazard resistant building design. Okay, now what do we mean by hazard resistant building design? That means when you design the building and when you build the building, how does it affect the structure and the materials? Okay, so how do I make it hazard resistant? Basically, through advanced engineering, they do a lot of testing. They will find ways to have designs that will help prevent the building from collapsing, for example. Okay, and they would also implement laws, make it compulsory for all the new buildings to implement all these design. All right. Then the older buildings, how? Older buildings, well, they will get them to implement these designs. Retrofit lah. What does retrofit means? Retrofit means after they build it, after it's already there, I add on. Okay. It's just like you will add on another layer of clothing like that. All right. So this building design, what's the for earthquakes? What does it do? Well, basically, they can get them to make it thicker walls and pillars so that it's more resistant to shaking. Okay, they may have all these designs like dampers, base isolation, cross bracing. Okay, then of course sometimes tsunami proof can happen. They make sure that buildings have deep foundation. The buildings go deep underground so that when the waves come in, it will not be washed away so easily. Sometimes they may have the first floor empty so that people are not living there. Okay, so that when the waves come in, nobody is in the first floor to be washed away. All right. So you can see some examples in page 5. Okay, so this one is Taipei 101. This huge pendulum, physics student. This looks like a pendulum, right? Okay, yes, it's like it's meant to be like pendulum. So when the building shake, right, the pendulum, the damper will move in the opposite direction and pull it back. Okay, so that's what mass dampers do. Base isolation, like this is the bottom of the building. So base isolate means I separate them. So what does base isolation means is that I separate the base of the ground from the base of the building through these things. So what happens is that when the building shake, right, the ground can shake left and right, but these parts will, the black color part will shift, it's flexible, okay, and then the buildings above will remain stationary because of inertia. Okay, sometimes they may install, so this is an old building, then they added these diagonal diagonal braces to hold the structure better. All right. And then of course we also have buildings with tsunami proof. So you can see this one, the first floor is empty, so that if there's a tsunami coming, they can escape to the second floor, and then the water can wash through without damaging the building. Okay, so you might realize, how come here talk about earthquake, tsunami, but the others could talk about volcano? So what about volcano? Okay, from what we understand, there isn't much volcano resistant design. All right, because when a volcano erupts, the lava is really not quite possible to stop. It is hot melted rocks. Okay, the amount of ash it comes out is so much, amount of lava is so much, pyroclastic flow is so fast and hot, so it's very difficult to build buildings that can resist all this. Okay, but what some countries do is that they actually have infrastructure to manage some of the hazards. So in Indonesia, Mount Merapi, they actually built walls, here also another word, walls, and channels so that when the lava mud flow comes in, it will be blocked and forced to change direction and move away from the villages. Okay, so this is one way that they can manage. All right, now what are some of the other building designs? Okay, let me show you. This is a simulator from the Kobe Earthquake Museum. It was meant to commemorate the 1994 Kobe earthquake, the Great Hanshin earthquake. Okay, so the one in front here, a bit blurry, okay, is the typical building design that we see every day. So there is pillars, there is beams. Okay, so when he simulate the earthquake, what happened to the shaking? All right, now the one behind is one of the earthquake resistant design, or one of the things that they retrofit older buildings with. They put cross braces. Okay, and then the one in the back is not a very well done base isolation. So you see the rollers here. That means when the thing shake, the building is not directly in contact with the ground, but it's in contact with the rollers here. Okay, so I'm going to observe which of these three shake the most. Okay, okay, so which one shake the most? All right, so yes, obviously the conventional one shake the most. Now in real life, okay, no buildings can shake, turn so much, tweak so much. Okay, in real life, once it move away too much, the building will lose its support and will collapse. Okay, now you can see that the base isolation shakes much lesser than the typical design, and the cross bracing one also hardly any shaking. Okay, so this is an example of earthquake resistant design. Okay, now here's another one. All right, here's another earthquake resistant design. Okay, this is what they retrofit old buildings. So just now the old buildings in front, typical design, right? What do? They may actually strengthen the wall. they may force them to make a thicker wall, a stronger wall, to hold the building better. So they added this stronger wall here. Okay, let's see what happens to the building. Okay, so you can see before they added the wall, it shake so much. After they add the reinforced wall, it hardly shakes so much anymore. Okay, so these are examples of earthquake resistant design. So with all this having there's less chance of the buildings being damaged and collapsing. Then of course it reduces death and injuries and infrastructure damage, DID. Okay, and like what we talked about just now. All right, why does it make a community more resilient? Because with less death and damage, it's easier to recover, and they feel safer, so they will stay and they will not move away. Okay, now I'm going to pause the video briefly. I want you to discuss, and you want to discuss your partner, you may do so, and find out what are the limitations then. Okay, so some of this, one of the limitations is that all these design can be very expensive to implement. You need a lot of technical expertise, okay, or you put here as technical resource. Okay, and you need a lot of money, financial resource to implement all this. All right, so why does it make it less effective in disaster risk management, community resilience, and sustainability? Okay, you can use the previous page to help you, and I'll give you some time to think through. And once you're ready, just press play. To just pause. We're going to pause the video now, and once you're done, just press play. Okay, have you decided already? Okay, so let's try to explain. So with less financial and technical resources, what happened? That means it's less likely to implement all these lah. Okay, and where does this happen? It usually happens in LDCs. Okay, so since they can't implement this easily, the buildings continue to be easily damaged by these hazards. Then what will happen? It will continue to be vulnerable to damage. Okay, more likely to collapse and then go back to disaster, continue to cause a lot of death, injuries, and damage. Okay, so if there's a lot of death, injuries, and damage, it's harder for the community to recover because they need a lot more resources to recover. Oops, sorry, Okay, and then when it's harder to recover and there's more death and injury, it's less sustainable because people will be more traumatized. They don't want to stay anymore. Okay, so this is quite similar to the one above. All right. Okay, so if there's nothing, let's move on to the next measure. Okay, I'll jump to the last one. I will skip the third one. Okay, this part you try to do it on your own. Okay, you can use the resources here to help you, and I'll just jump to the last one. Okay, so for the last one, how do we then prepare? How do we then reduce disaster risk management? Well, we increase the preparedness for responses and recovery. Okay, so you have learned about disaster management, how we respond, how we recover, right? So what can be done to prepare for that more? Okay, so the most common one is to do public education. You help people understand what are the hazards, and then where to take shelter, what to do when something happens. All right, you can train them. Okay, so in the community, you can train people to have basic medical care, know how to do first aid, so that you can they can administer all these and prevent deaths. All right, and of course you can always have drills, right? In school we have fire drill, right? Okay, so in these countries they have all these evacuation drills, okay, to so that people know how to evacuate, and then the medical services will get ready their processes. Okay, so in Japan what they do is that once a year they will have this disaster prevention day. All the schools will do a quick drill. All the civil defense will do a drill to improve their response time. All the hospitals will rehearse when the earthquake happen, what must they do, what must they set up so that they can attend to as many patients as possible quickly. Okay, so so for example, earthquakes, they try to have drills to avoid downwind, minimize exposure, how to evacuate quickly. Okay, earthquake, they actually learn how to protect themselves from falling debris, how to evacuate quickly, and tsunami also, how do they evacuate quickly also. All right, so these are some examples. Okay, so in primary schools in Japan, this is Japan, okay, the students actually have this this safety hood portable with them. So they are trained such that when the earthquake happens, they just put on the hood quickly to protect their head from debris. Okay, then this is also in China. A lot of places in earthquake prone, they'll teach the kids, right? When the earthquake strikes, quickly hide under the table. Use the table to protect yourself from debris. Okay, then this is the first responders, the hospital. There's like the civil defense lah. Okay, that means they are practicing on disaster prevention day. How to respond quickly to mass casualties. Okay, this is an app, pictures of app, screenshots of apps, an app that is created by Tokyo in Japan. All right, so it basically teaches the people there how to get ready for disasters. Okay, how to prepare your food supply, what are things to do when disaster happen. Okay, now in many places that is tsunami prone, they actually marked out with signages that is a earthquake zone, so please look out for tsunamis. And when the tsunami happen, where do you run to evacuate? So for this case in South Thailand, Konak, South Thailand, if you want to go to the evacuation place, you must run 200 meters in this direction. Okay, so you need to prepare all these things to make sure that when the disaster strikes, people can respond quickly and then recover from there. Okay, of course, governments and community need to work together. Okay, to come up with all these plans to set aside resources. Okay, and they also have like what I mentioned just now, they also have infrastructure and facilities to help with the recovery and response, like the signages. All right, so this is explain why is it that it helps people to recover, to reduce disaster risks, to improve community resilience, to make it more sustainable. Can I pause the video and I want you to try to explain why is it that it doesn't work so well in some places? Okay. All right, are you done? Okay, so let's take a look at this. Why is it that it cannot work in some places? So basically, you need a lot of financial and technical resources, like just now, like the previous responses, measures. Okay, I need a lot of money to train, to prepare people, to prepare all this infrastructure. I need the technical expertise to know how to set up all these systems. Okay, all the process that's most efficient. So because of that, LDCs being poorer, less resources, unlikely to afford. Okay, so if I can't afford to train my people, what will happen? If they are not trained, they are not prepared, most likely they will panic. Okay, they don't know what to do, and then they don't know how to protect themselves in a timely way. So that like earthquake happen, they don't know what to do, then they cannot protect themselves, they don't know how to protect themselves, then they get hit by debris and then they die. Okay, or hospitals don't know how to respond, so a lot of patients are left waiting, then they die. All right, what else? What else actually prevent them from being able to make it effective? Okay, so sometimes I do not prepare, cannot afford all this preparation or resources, so the community don't have the resource to recover and respond effectively. Okay, so in Japan, a lot of the villagers, right, the village leader and the village committee have loud hailers, have all these evacuation route, have all these blinking lights, all these things, right, to guide people to safety when tsunami strikes. Okay, to evacuate as quickly as possible. So they have all these resources prepared in more developed countries, but less developed countries maybe not so prepared because they don't have the resources. Okay, so if you can't help people to respond and respond quickly, you continue to have a lot of death and injuries. And with the same line argument, more death and injury, harder to recover. Okay, and harder to recover means also harder to last in the future because people don't want to stay there anymore. Okay, so now that you have done this, all right, this is what we want you to do. Number one, we want you to try page 6, monitoring and warning system. Okay, once you are done with page 6, I want you to try this one. Okay, so community resilience, resist, adapt, respond. So we have learned about disaster risk management and disaster management already, right? Okay, so these are the things we do when we manage a disaster, and these are things we do to manage disaster risk. So I want you to tell me, resist impact, adapt impact, respond and recover from impact. Which one belongs to where? Okay, they can be in more than one places. All right. Next one, I want you to label in the diagram which one attempts to manage exposure, which one attempts to reduce vulnerability. Okay, and we want you to group from all the responses above. What are the two common reasons why the disaster management, risk management can be limited in its effectiveness? So you see all these right column. What are some of the common things? Okay, question 4 and 5 we will discuss in class. So hopefully through today's lesson you have a better understanding. Okay, how do we prevent disasters from happening? How do we reduce the risk, the chances of disaster happening? Okay, how do we manage the exposure? How do we manage the vulnerability? And as a result, how do we then build the community's resilience? How do we help them recover faster? All right, so continue with your work and see you tomorrow.